Now that we've added provisioning services on the master node, we can go to the next step. We're going to add resource management services in the master node, and we're using Slurm for this. So we will install the OpenHPC package for Slurm. This is a 22 meg download. After we've installed the Slurm server meta package from OpenHPC's repository, we need to identify the resource manager hostname for the master host in the Slurm configuration. Before we jump into this Perl command, which will search and replace with our SMS name, let's add a new tmux pane. We're going to watch the line that we intend to change. It's currently by default set to Linux 0, and we're going to run a Perl command, this Perl command, to replace it with our SMS name. And we can recall the SMS name for our VM by default in this demo is SMS-host. So we expect this to be replaced by SMS-host. I'm going to cheat a little and do a copy. Let's just give ourselves a little more real estate. Now that we're ready, watch this screen here. Linux 0 should be replaced by SMS host over here. Watch here. The regular expression command has updated the control machine to our VM. Just to verify that our DNS is working, it might not be a bad idea to ping the SMS host from our server. And it does resolve to localhost, as it has been defined there. A few more parameters need to be tweaked on the Slurm configuration file for the OpenHPC virtual lab. Let's see what the default settings are. This is the Slurm configuration file, and we'll look for the line that defines the sockets. The original default settings in Slurm have node names of C, 1 to 4, dual sockets, 8 cores, with hyperthreading or symmetric multithreading enabled. For our virtual lab, we're going to go quite sparingly on the resources for the VMs. So we're going to pare this down. Again, because it's useful, we're going to make sure that our changes are correct. We're going to be implementing another regular expression Perl command to replace the parameters. This is going to replace the dual sockets to single sockets. We're also going to change cores per socket from 8 to 2 for dual core. This value here will change to 2. And then finally, we're going to turn off hyperthreading or symmetric multithreading. It's currently set at 2, and we want it to be set to 1. And now everything's been set to the parameters that we want to use for our virtual lab. Now we've defined the hardware parameters for the virtual machines to be managed by Slurm in terms of sockets, cores, and threads. But we need to make sure that the node names are also correct. We're running 2 compute nodes in this lab. They're defined as C_name 0 and C_name 1. These resolve according to the setenv file to compute 00 and compute 01, and not C1, 2, 3, or 4. We'll do this using Perl. Again, we'll search for node name is equal to C. Now it's a special character, so you need to break it. We'll replace it with node name equals compute 0, 0 to 1, and define the slurm.conf file. Take a look here. C should change to compute, and the 1 should be 0, 1, and 0. Now node names are defined as compute 0, 0 and compute 0, 1. And now we've configured Slurm to talk to our two virtual compute nodes. We won't be adding InfiniBand support in this virtual cluster. We can skip that. We will not be adding OmniPath in the virtual cluster, so we can skip that. In addition to renaming the compute node names for Slurm, there is one other section that we need to check on the Slurm configuration file. And that is the partition name, where nodes is set to C. Now searching for both references, we should see that node name, compute 0, 0 to 1, should correlate with nodes, compute 0, 0 to 1 for the partition. Running the Perl command, we will search for the reference of nodes equals C 1 to 4, and we will replace it with nodes is equal to compute 0, 0 to 1, watch the right hand screen. We should expect this line to be updated to compute 0, 0 to 1. And we've updated the partition name to match the node name to match the computer names. The next section will be completing the basic XCAT setup for the master node.